Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 2259. Remove digit from number to maximize result. You are given a string number representing a positive integer and a character digit. Return the resulting string after removing exactly one occurrence of digit from the number such that value of resulting string in decimal form is maximized. The test cases are generated such that digit occurs at least once in the number. So they will give a number and also a character digit. We want to remove a character digit from the number at least exactly one time, and they have given that the number should contain the digit at least once. So this makes sure. Okay. So the resulting string should be what? Maximized. We want to just remove a occurrence so that my resulting string will be what? Maximized. So let us see the examples. See here. In this first example, 1, 2, 3, I want to remove 3. I want to remove 3. But I only have only one 3. Just remove it. My value is 4. No problem. Now take this 1, 2, 3, 1. I want to remove what? I want to remove 1. Okay. So if I want to remove 1, I can either remove this one or I can remove this one. So I have two possibilities. What? I can either remove the last one or I can either remove the first one. So what is the maximum value? I can say this is the maximum value. Yes. Again, take this 551. In this example also, we want to remove what? 5. Okay. I can remove this 5 or else I can remove this 5. So I can remove the first 5. It results in 51. Also, if I remove the second 5, it also results in 51. What is the maximum? It will be 51. So 51 will be my output. So this is what the question. So for this question, I can say just remove each and every characters. Just remove every occurrence. Remove each occurrence. First point. Second point, check for maximum value. Check for maximum value and then return that value. So this is my approach. Right? Take for example, for this, I just remove this, and also in another case, I have removed this, and I check which is greater. This is greater. So just return it. Right? We can also have multiple times. Just see here. We can also have like this. Okay. In this scenario, which should be removed so that I can get a maximum count. I can say this one should be removed. Yes, I can remove this one. If I remove this one, I will get the result as 2, 3, 1, 3, 1, 2. If I remove this one, I will get result as 1, 2, 3, 3, 1, 2. If I remove this one, I will get the result as 1, 2, 3, and then 1, 3, 2, which is greater. This is greater. So I have to remove what? The first one. I want to remove what? The first one. So this is the brute force approach. Brute force approach. Okay. Can we optimize it? Yes. Yes. Let us check how to optimize it. Let us take this example. 1, 3, 1, 2, 3, 1. If this is my example, if I remove this one, I'll get the least number. If I remove this one, I'll get the maximum number. Why I have to remove this? I have two numbers, but why should I give a priority to this number? Because 1 is less than 2. 1 is less than 2. If it is less than 2, I can say, if I remove this one, I will get the maximum value. Just observe, if this is the case, I have to remove any one value. If I remove this 7, I will get the maximum place. If this is the value, just take for example, this is the value. If I remove again this 7, I will get the maximum value because this 7 is less than the next value. So that if it is removed, the next value will occupy its position so that I will get the higher value. So this is the basic knowledge we have got. So we have come up with the solution like first thing is we want to delete a value such that the next value should be greater. Next should be greater. Right? So this is the first observation. And then what is the second observation? If there is no value exists such that, let us say 3, 2, 1. We want to delete 3. Let me take another color. We want to delete 3. If I delete this 3, I will get the maximum value. But whether this 3 is less than 2, no. Then I want to take the first occurrence. If there exists only one value. So this is my second case. And then what is my third case? If I have multiple values, if I have multiple values like 3 and then 2 and then 1 and then again 3, again 2, again 1. Fine. Now, which value should I remove? I should remove which value? This 3. I should remove this 3. I don't want to remove this 3. So this is the another case. Remove latest. If all do not satisfy the condition, all not satisfy condition. So these are the just observation we have noted. Okay. So these are the observation. Let us write the code. See here, first of all, I will write the code for brute force. Check here, brute force is, see here, f is equal to empty string inside it 0 for I in range of len of number. If number of I is equal to digit, then f is equal to number of till I am just slicing, and then from I plus 1 I am just slicing. It means just see here, if you are not from the if you are not from the Python background, just see here, I just take from this, if just take as an example, see here, if this is the case, I want to take this 2 and also this 2, then how can I take? I will slice this, I will take this substring and this substring and just concatenate them. So that's the case here. If you are from C++ or Java, you may do by using looping, or else you can also use the substring method. Okay. If int of s is greater than int of f, then f is equal to s. I just updated, right? Now return the f. That's all about it. Let me submit it. So it is a brute force approach. Talking about a time complexity and space complexity. What is the time complexity and space complexity for brute force approach? See here, we are using. Let me write here. So brute force approach, time complexity and space complexity. So what is the time complexity? I can say the time complexity is O of n for traversing each and every string, and also another n for just updating the every substring. So I can say it is as O of n square, and the what is space? It is empty. We didn't need any space. We are just using the resultant variable. That's all. So this is the brute force approach, time complexity and space complexity. Now let us see the optimal approach. Just see here. This is the optimal approach. First of all, I am just initializing the two variables, index and the first occurrence. Then for I in range of len of number -1 to 0, then -1. Okay. I'm just going from reverse order, and in the reverse order I want to take the first occurrence. See here, in this third case I have given right. In this third case, remove latest element if all are not satisfied. That's why if it is latest from left to right, it will be what? It will be nearest to right to left, right? So that I am just traversing from this way. Just observe, I'm just traversing from this way. Okay, from this way, and I'm just storing the first occurrence in the first occurrence variable. Fine. If there is no such condition exist, then I will remove this first occurrence, not this element. Okay, if as condition exists, I will remove that element. Okay, fine. So that's why I am just traversing from reverse order. Okay, if number of I is equal to digit, then if number of I is greater than number of I minus 1, I will say index is equal to I and then break. Right. So this is a condition. Okay, let us see the optimal code. See here, I just declared index is equal to -1 and last occurrence is equal to -1. Now, for I in range of len of number, if number of I is equal to digit, if it is equal to digit, then I have to do check for if I plus 1 is less than the len of numbers. If it is so, I can directly check number of I is less than the number of I plus 1. That's what we have seen here, right? See here, delete the next, delete if the next should be what? Greater. If the next is greater, then we want to delete. So that deleting index should be stored in index. Okay, if that's the case, we want to break. But still, in every iteration, we want to check for the last occurrence, because see here, the third case is remove the latest if all are not satisfied. If the condition is not satisfied, we want to remove the latest. Okay, so remove the latest, we want to find the last occurrence of that number. So to find the last occurrence of that number, I am keep on updating my last until I just terminated the loop. Okay, now if index is equal to -1, I can say if index is equal to -1, I didn't satisfy this condition. I didn't satisfy this condition because initially it is -1. If it is -1, I didn't satisfy this condition. So I can say I want to do, I want to delete the last occurrence. How to delete the last occurrence? I just not deleted the last occurrence. I just done the string slicing by which we want to take the number up to the last occurrence and after the last occurrence. That is this here, this like this. If 2, 3, 1, 2, 3 means I just take this 2, 3 and I just take this 2, 3 and then I just concatenate them, right? So this is what I have done here. And if this is not the case, I will return what? I do the same for the index. I do the same for the index. Okay. Now let me submit it. So what is the time complexity and space complexity for this approach? Let us analyze it. Yes, it is submitted successfully. Let us analyze the space complexity and time complexity. So tell me what is space complexity and time complexity. My time complexity will be O of n because I am just iterating only one thing. Yes, I am just traversing to the each and every characters only one thing. Okay, so it is what? O of n. And then what is space complexity? It is O of 1 because I am using only the result string. Instead of that, I didn't use any other. Okay, so this is the optimal approach. Thank you.